Welcome everyone. In this video we'll look at rate of reaction. The question involves the rate equation with links to concentration time graphs. It's from an A-level chemistry past paper. Details are in the description. Let's get started. Here's the information given at the start of the question. Iodide ions are oxidized to iodine by hydrogen peroxide in acidic conditions, and we're given a balanced equation. The rate equation for this reaction can be written as rate is equal to K multiplied by the concentration of hydrogen peroxide to the power of A multiplied by the concentration of iodide to the power of B multiplied by the concentration of H plus ions to the power of C. In an experiment to determine the order with respect to H plus, a reaction mixture is made containing H plus with a concentration of 0.500 mole per decimeter cubed. A large excess of both H2O2 and I- is used in this reaction mixture so that the rate equation can be simplified to rate is equal to K1 multiplied by the concentration of H plus to the power of C. Here's the first part of the question. Explain why the use of a large excess of hydrogen peroxide and iodide means that the rate of reaction at a fixed temperature depends only on the concentration of H plus ions. Using a large excess of hydrogen peroxide and iodide means that the concentration of these reactants is virtually constant compared to the change in concentration of H plus ions. We can say that the change in H2O2 concentration and I- concentration is negligible. This means that the concentration of these reactants do not affect the rate. Here's the next part of the question. Samples of the reaction mixture are removed at timed intervals and titrated with alkali to determine the concentration of H+. State and explain what must be done to each sample before it is titrated with alkali. We need to find the H+ concentration at specific points in time after the reaction begins. When the samples are removed, the reaction must be stopped immediately, or at least as quickly as possible. When a reaction is stopped like this, we say that it is quenched, and this is a good term to learn. It was on the mark scheme for this question. There are a couple of ways to do this. I think the most effective way is by adding a reagent to react with the H2O2 or I-. Here's the next part of the question. A graph of the results is shown. Explain how the graph shows that the order of reaction with respect to H+ is 0. Concentration time graphs and concentration rate graphs can both be used to work out order of reaction. The shapes of these graphs are shown here. It is a good idea for you to try to remember the shapes of each of these graphs. The mark scheme for this part of the question was very specific. Answers such as the graph is a straight line or the relationship is inversely proportional were not considered detailed enough to gain credit. To get the marks, students had to state that the graph has a constant gradient as H+ concentration changes. Here's the next part of the question. Use the graph to calculate the value of K1. Give the units of K1. Before addressing the question, I thought it might be worthwhile looking at the rate equation. Rate is equal to K1 multiplied by the concentration of H+ to the power of 0. So the order of reaction with respect to H+ concentration is 0. Any number raised to the power of 0 is 1. So the rate equation becomes rate is equal to K1. This illustrates why the rate concentration graph is a horizontal line and the y-intercept is equal to K1. However, we have a concentration time graph, so let's move on and address the question. Rate is equal to change in concentration divided by change in time, and since rate is equal to K1, then K1 is equal to change in concentration divided by change in time. To find K1, we need to calculate the gradients. It is a very good idea to annotate graphs clearly, mark the points that you will use to calculate the gradients and give their coordinates too. K1 works out to be 1.19 times 10 to the minus 3. We have divided concentration by time, so units are moles per decimeter cubed per second. Here's the next part of the question. A second reaction mixture is made at the same temperature. The initial concentrations of H+ and I- in this mixture are both 0.500 mole per decimeter cubed. There is a large excess of H2O2. In this reaction mixture, the rate depends only on the concentration of I-. Plot these results on the grid. The first 3 points have been plotted. You've probably heard this many times before, but here it is again. Use a sharp pencil and place a cross clearly in the grid for each point. Many students lose marks unnecessarily because they rush questions like this. The crosses for each point are marked on the grid in blue. To get the mark, each point had to be plotted to within one small square of the correct value. Here's the next part of the question. Draw a line of best fits on the grid. A smooth curve is necessary that passes within one small square of each of the points. This should be a single line. Practice drawing lines of best fit if you lack confidence. It is possible to buy flexible curve rulers or flexi-curves to help you. These are allowed in exams. Here's the next part of the question. Calculate the rate of reaction when H plus concentration is equal to 0.35 mole per decimeter cubed. Show your working using a suitable construction on the graph. Once again, annotate the graph clearly using a sharp pencil and ruler. Take some time to line up your tangents. A transparent ruler can be helpful so that you can still see the line of best fit. A longer tangent helps with accuracy. I have drawn a right angle triangle and annotated the coordinates that I will use to calculate the gradients. Rate is equal to change in concentration divided by change in time. This works out to be 4.29 times 10 to the minus 4 mole per decimeter cubed per second. There is always some leeway on mark schemes when working out gradients. Once again, if you show you're working out clearly, you give yourself the best chance of being within the required range. And if you fall outside the required range with your final results, you should still get plenty of method marks. Thanks for watching. I hope you found the video useful. Please don't hesitate to post in the comments if you have any questions or suggestions. Take care and good luck with your studies.